Okay, today we're going to continue on with our discussion on quadratics. Particularly, we're going to look at a couple different word problems, and we're just going to evaluate what the graph and what the table of values tells us based on the information. So the first thing I'll do is I'll show you the answers to the homework that you had. This one, so you had was it pizza pieces? What the graph would look like. There's some answers again to the pizza pieces on this part of the page. Bacteria growth. Now, as far as coming up with the equation for each one of these, I'm not expecting you guys to do that. We are not there yet. If you did, great. If you didn't, that's not a concern for me right now. Okay, so don't worry about coming up with the equations. Now, I'm missing a title here on this one, so don't forget a title. There's some more answers to the previous question. And then the frog's growth. No, you didn't have to do that one, I don't think. Oh, yeah, you did. The frog's growth here. Right, there are the answers to that. And then again, some summary questions. All right. So on page 54, take a second and I want you to read this problem. And remember what, like I always say, that if you read a word problem and you don't understand it, what do? You read it again. And if you read it again and you don't understand it, what do? You read it again. You read it 3 times at minimum to see if you can understand what's going on and maybe pick out some key pieces of information that's going to help you with the problem that's going to be coming. If you don't understand it, then just kind of walk away and come back to it and try reading it again. At that point, then my suggestion is that you ask someone else to help you. But always read a question 3 times before you start working on it. So I can't remember if I gave you this table completed or not already, but these are the values that I'm giving you for that situation. I can't remember her name. Does she have her name? No, it's just the players. Okay, so the players are running, and this is going to be one player. So I want you to take a second, and I want you to calculate the first differences in each one of these cases and calculate the second differences and identify what's going on. So you guys go ahead and do that. Pause the video and do that for me, please. All right, so this is what you should have gotten when you calculate your first differences. So I did my first differences here. I got nonlinear because they were all the same. And then I did my second differences, and I found that all those values were exactly the same, and they were quadratic, which tells me that it's quadratic. All right, now take a second, and I want you guys to graph this. Remember that I want you to use as much of the graph as possible. Now let's identify our independent and dependent variables first. So identify our dependent and independent variables. Remember that when we're identifying our independent and dependent variables, the independent go down here, and the dependent go along this axis. Now, what's going to go on the x-axis and what's going to go on the y-axis? Well, generally speaking, not always, but pretty much for every case that you guys encounter in this course, the time will always be your independent. And then your distance will be your dependent variable. Now, this is going to be pretty much the case for everything, like I said, in this course, but it's not always the case. When you guys get into physics, sometimes time may be a dependent variable. So for question 1, I'm going to say that time is independent. And for question 2, the distance is dependent. Oops, not an A. Gotta put an E in there. Sorry about that. Is dependent. Okay, so take a second, graph your points from the table of values, and then see if you can identify whether or not the points on the graph should be joined. So think about why we join the points and whether or not these ones should be joined. So take a second and do that. All right, so this is what your scatter plot should look like. So when I plotted just the points, I haven't joined any points yet, I just plotted the points. Now explain whether or not they should be joined. Well, yes, they should. Oops, I guess I need to erase some of this. Yes, the points should be joined because you can have partial values, and we went over this. Could you have a half a second? And if you have a half a second, could you have a part of a meter? Absolutely. So that's why you can say that these points can be joined. Okay, based on the graph, is there a way to determine how far the wall is from the detector? How far is the wall from the detector? And yes, you can. Oops. The detector is 16 meters from the wall. This is where the detector started, was right here at that point, right here at the beginning, which means she's going to the wall and coming back. So that means the wall is 16 meters away from the detector. Now, once Janice passes the detector, how long does it take her to reach the wall and pass the detector again? I don't know why I have again here. But how long does it take her to get to the wall and then come back? Total time would be 4 seconds. Where is the detector in relation to where Janice started to run? Now, this is a question where, like I said at the beginning, when you read a word problem, you need to read it and understand it. And if you don't understand it, read it again. So if we went back and we looked at the question here, it says, the coach of the basketball team had her players practice the following warm-up activity: run towards the wall, touch it, and then run back. To analyze their runs, she placed a motion detector to record their efforts. The coach triggered the detector on as the player passes. So this tells me that if this is my detector right here, not much of a detector, here's the wall, I want this has to detect when they go past. So as the player passes. So as the player is running in this direction, the detector gets triggered right here. So where does the player start? Well, the player starts over here then. Okay, so that's crucial when we're trying to answer a question like, is it this one? Yeah. So the detector is between the wall and the point where she started her run. Okay. Now, is this relationship linear or not? It's not. We found that from calculating the second differences. This graph is nonlinear. And then use the table to show the first, in which we already did this. Okay, so the first differences decrease by 2 every time. So if we look at the first differences, we're going down by 2, 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 down by 2. Now, I know I said when you calculate your first differences, you always go from bottom up, but you can look at them in the reverse order as well. Okay, and then how do the first and second differences relate to the shape of the scatter plot, or the graph in this case? Okay, since the first differences vary, the second differences are constant, the function is quadratic, and therefore the graph is in the shape of a parabola. Okay, let's move on to this one. So an astronaut launches. So an astronaut launches the rocket from a launch pad high above the ground. So right away, that little bit tells you something right off the bat. Okay, if you don't understand it, you don't see why, read it again and figure that out. Its height, h in meters, at time t in seconds, is given by this equation. Complete the table. So what I want you to do is I want you to complete this table of values using this equation and using these points down here. I want you to use all these points. So I'm going to go through it, go through one example, and I'm just going to take the first example. So I'm going to take my equation. This is my time. So I'm going to take my equation of h is equal to -5. Replace my t with brackets squared plus 30t. Replace the t with brackets plus 35. Now I'm going to sub in what my t value is, 0.0. And then do my calculations. Okay, I would then solve this. And in this case, I'm just going to get 35. So my answer is 35. So I want you guys to take a second, and I want you to calculate all of these values, and then calculate your first differences and your second differences. Okay, so pause the video and do that for me. Okay, so this is what you should have gotten for your heights and all your first differences and your second differences. Now let's talk about these second differences a little bit. This negative symbol right here tells you the direction of opening. Okay? I know that this is a parabola based on this. Okay? And because it's negative, it's going to tell me that it opens down. And if you think about what's going to happen when you launch a rocket into the air. So if I have to draw a little graph over here about what I think is going to happen. Now it says the launch pad is high above the ground. So it's going to be up here somewhere. And it's going to look, the graph is going to look something like that. You're going to launch it up, it's going to go to a maximum height, and it's going to come back down and hit the ground. So this is what your graph should look like, something like that. And the negative tells you that your graph opens down. Now this negative here up in front also tells you that. But just looking at the second differences, that's what you can identify. Okay, so you know what the graph should look like. So I want you to take a second, pause the video, and then I want you to graph it, and then I'll show the answer here in a second. And then I'll answer this question as well. All right, so that's what your graph should look like, something like that. And it's just like the diagram I drew on the previous page. You're going to start at a certain point because the launch pad was high off the ground. You're going to go up and you're going to come back down. The rocket's going to hit the ground. Now, does it make sense to connect these points? Now, this graph is not drawn very well. It should be a nice smooth curve. But does it make sense to join the points? And yes, it does. This is another situation in which you can connect the points because you can have partial values. All these values are continuous. Time is continuous and height is continuous. Okay, so let's answer these questions. Now, again, this here, I would encourage you guys to pause the video, try to answer these questions without looking at the answers, and then I'll come back and I'll show you all the answers. Okay, so let's talk about these answers that we got. Is the relationship linear? Well, no, we calculated the first differences and they vary, so it is not a straight line. What does the height at time equals 0 represent? So at the height of time equal to 0, I know my graph, oops, let me get my pen working here. I know my graph is going to look something like this. The height at time equals 0 is right there. And that represents the height of the launch pad. It's the starting point of the graph. And that is the y-intercept in the equation. How long does it take the rocket to fall back down to the ground? To the height of the launch pad. So to the height of the launch pad, I guess I'm going to have to go back here. So that was question F. Oops, this one. The height of the launch pad is right here. So approximately how long does it take to go from here to here? Well, it takes 6 seconds. Okay, so that's why it takes 6 seconds here. Now, what is the maximum height of the rocket, and how far above the launch pad is the rocket at this time? Well, the maximum height is 80 meters, and we get that from just from the turning point or the vertex of the parabola. But if I want to know how far above the launch pad the rocket is, well, the maximum height, you would take the maximum height and then subtract the height of the launch pad, which equals 45. Now, what is the rocket doing between time equals 1 and time equals 2? Well, the rocket's going up. When does the rocket hit the ground? Well, it hits the ground at 7 seconds. And that's just the point in which, so if we go back to this, it hits the ground right here. Right down here at this point is where it hits the ground. So those are all the answers to those. And like I said, we were just looking at graphs, coming up with a table of values, and then just evaluating the graph, evaluating the table of values, and pulling information from those items, okay, from the graphs and the table of values. So there's your homework. And again, I will remind you guys and girls that do what you can, okay? Because of the COVID-19, we are just doing a limited amount of homework, and I don't want you guys to go through and go crazy and spend hours and hours on homework. Do what you feel is necessary and prepare you for the types of quizzes and tests that you guys are going to be doing, okay?